Hey everybody, welcome back to your next video lesson. This one's going to be on isotopes. Now I made reference to isotopes in a previous video lesson, but now we're going to talk about specifically what they are. Now, what we need to know about isotopes is that isotopes are versions of the same element, but they have different mass numbers. And the only way you get a different mass number is if you change the neutrons. You can't change the protons of an element because that will fundamentally change what the element is. For example, lithium has 3 protons. If you change it to 4 protons, it becomes beryllium. If you change it to 5 protons, it becomes boron. So you can't change the protons, but you can change the number of neutrons to make it heavier or lighter. Now, the problem with making it heavier or lighter is that if you add more neutrons to the nucleus, it may destabilize the nucleus and might maybe break down. This is what is called radioactivity, but that is for another video lesson and another time. But for now, we're going to talk about what happens when you change the number of neutrons and how it affects the mass. So if you change the electrons, it gives you ions, which we talked about in a previous video lesson. But the neutrons are the key to determining the different types of isotopes. Now, an isotope is identified by its mass number because, of course, they have the same number of protons, so they're the same element, but they have different masses. For example, hydrogen could be 1 proton and 0 neutrons. In this case, its mass number is 1. And hydrogen could have 1 proton and 1 neutron. In that case, its mass number is 2. And this applies to all elements on the periodic table. Most elements on the periodic table have more than one isotope. Some only have 1, but there's a good chance they have 2, 3, or even upwards of 10 different naturally occurring isotopes for any particular element. Now we're going to do the same thing that we did with the last video lesson when we counted the number of protons, neutrons, and electrons for different elements and different ions, but now we're looking at different isotopes. These are 3 versions of carbon. You got carbon 12, and remember the name 12 means that that's the mass number, not the atomic number. Carbon 13 and carbon 14. So they're all carbon, so they all have an atomic number of 6. The mass numbers match the masses that were in their names. And so when we look at the protons, neutrons, and electrons, it's really very similar. Pull out your periodic table if you need some help. But since its atomic number is 6, it has 6 protons. Now, in order to figure out the number of neutrons, right, we take the mass number minus the atomic number, and this has 6 neutrons. And finally, since they are neutral isotopes, means they're not charged, they're not ions, then the protons will have the same number as the electrons, and so in this case, electrons equals 6. Now for the next isotope of carbon, we have 6 protons because, well, it's carbon. This time, though, 13 minus 6 is 7 neutrons. And because it's neutral, it has the same number of electrons and protons, so 6. I think you get the idea, but let's do it again. Carbon 14 has 6 protons. This time it has 8 neutrons because its mass is 14, and once again, 6 electrons. So as you can see, the only difference between these is that they have different neutrons, which gives them different masses. And you might be wondering, what's the big deal? Why do I care about elements with different masses? Aren't they all just carbon? Well, no. The point is, as I mentioned earlier, that sometimes when you have too many neutrons in the nucleus, it changes the fundamental properties of that element or that particle. And in the case of carbon 14, although it occurs naturally, is radioactive and will decay over time, where carbon 12 is quite stable and will live for pretty much millions and millions, if not billions of years as carbon 12. But carbon 14 doesn't stick around very long because its nucleus is unstable. So every isotope brings with it its own unique physical and chemical properties. So that's why isotopes matter. Anyway, that's a quick video lesson on isotopes. Thanks for watching.